Hello, today we're talking about radical expressions and rational exponents. Our objective today is to simplify expressions with rational exponents. Now when you think of rational exponents, you think of fractions, so exponents with fractions in them. So the essential understanding is that you can write a radical expression in an equivalent form using a fractional or rational exponent. And this is going to help us simplify certain expressions and then ultimately help us solve radical or rational exponential equations. So here we have the nth root of a to the power of m. What we can do is we can rewrite this expression in its equivalent form as a rational exponent. So this is the radical form, and if we want to rewrite it as a rational exponential form, we can write it like this. So notice that the a, the base of my m, is the base of the exponent here, and the m becomes the numerator of my fraction, and the index, it just simply becomes the denominator. Okay, so that's how we can rewrite it into another equivalent form. So here are a few simple examples. So if we want to take these first two problems and we want to convert the following into radical form, notice they're in exponential form now, and we want to convert them into radical form. So I know I'm going to have a radical, and what I look for is the base. Well, the base is what is being raised to the power. So x is the base. So x is going to go inside as my radicand. My index is going to be the denominator of the rational exponent. So my index here is 2. So if my index is 2, I don't have to write it. I can say it's the square root. I could write a 2, but I don't need to. So let's go ahead and write that. I could show that, but I don't need that. And then the exponent of my x is going to be the numerator, so 1. And again, if your exponent is 1, you don't need that. So I can say x to the power of 1/2 is the same thing as the square root of x. So notice this is going to be something you should be able to simplify quite simply. Anything to the power of 1/2 is simply the square root of that number. Okay, now we look at 5 to the power of 2/3. So if we want to put it in radical form, we know we're going to have the radical. The base is 5, so that's going to be my radicand. Now my index is the denominator, which is 3. So my index 3 I do have to show. And then my numerator is the 2, becomes the exponent of my 5. Oh, sorry, that's not a 2. I didn't want that either. So I have the cube root of 5. And that's going to be to the power of 2, not 5. Okay? So now let's look at how to convert it into exponential form. So we're going to go in reverse. So we have the square root of x to the 4th. Well, the square root is just, remember, it's going to be 1/2. But here I have x to the power of 4. So my base again is 4, or x. My numerator of my exponent is going to be the 4, which is the exponent right there. And then my index is always the denominator, so that's going to be 2. And now notice I can reduce the fraction. So x to the power of 4 over 2 reduces to x squared. Notice if we were to take the square root of x to the 4th, we just divide the exponent by the index, 2, we would also get x squared. So now we have the cube root. The base is 7, the exponent 2 becomes the numerator of my fraction, and the index is the denominator, so 7 to the power of 2/3. Alright, now we're going to start talking about properties of rational exponents, and there's 6 properties that I want to talk about. And each one of them in of itself, I think, is not too difficult to understand. The difficult part in the ensuing examples are going to be figuring out which property to use in the example. So let's look at these properties. The first one, if we have a to the power of m times a to the power of n, we know that we have the same base. We can multiply, or I'm sorry, we can add the exponents together. So we can say same bases, we have a to the power of m plus n. So the way we'd use that, if we had a real number, a to the power of 1/3 times 8 to the power of 2/3, we can add the exponents. So 1/3 plus 2/3 is 3/3. And we know 3/3 reduces to 1, so that's just 8 to the power of 1, or just 8. So then we look at the second property, a to the power of m to the power of n. So what we do here, we have a term with an exponent being raised to another exponent. So we take this a and we multiply the exponents together. So we have 5 to the power of 1/2 raised to the power of 4. That's going to give us 5 to the power of 1/2 times 4. 1/2 times 4 is just 2, so we have 5 squared, which reduces to 25. Okay. The next one, a times b to the power of m. The way I think of this is by distribution method. So we can distribute that exponent to the a element and the b element. So we have a to the power of m times b to the power of m. And this is one where I see misused all the time. So we have 3x to the power of 3. And a lot of my students, they want to write this as 3x cubed. Well, that's not the case. So if we distribute that exponent of 3 to both elements, which is the 3 and the x, we have 3 cubed times x cubed, which that will simplify to be 27x cubed. Okay. The next property, we have a to the power of a negative m. Whenever we have a negative exponent, we don't like that. So we want to try to make that positive. And the way we do that is by taking the reciprocal of the term pretty much. So the a to the power of negative m can be thought of as over 1. We take the reciprocal of that, we get 1 over a to the power of, now it's positive m. So the way we would use that is if we had 9 to the power of 1/2 or negative 1/2, we take the reciprocal of that and now it becomes a positive exponent. Now we want to simplify that. Remember, anything to the power of 1/2 is just the square root of. So square root of 9 is 3. So we get 1/3. The next one is a to the power of m divided by a to the power of n. And we've done this before. And so what we do if we have the same base, we can subtract the exponents. So here we have x to the power of 5 divided by x squared. So what we would do here is we'd have x to the power of 5 minus 2, which is equal to x to the power of 3, or x cubed. The last one is a divided by b to the power of m. And again, we can simplify this thinking of distributing it. So distribute that m to the numerator and the denominator, each element. So we have a to the power of m divided by b to the power of m. And so how we would do this is we'd have 2, if we have 2/3 to the power of 3, we have 2 to the power of 3 over 3 to the power of 3, and we can simplify each of those. So 2 cubed is 8, 3 cubed is 27, and 8/27, if we were able to reduce that, we would. So here's an example of where we're going to have to use the properties of our rational exponents. Now, notice we have the 4th root of x cubed divided by the 8th root of x squared. Now, we don't have the same indexes. So what I want to do is I want to convert this into exponential form. So if I look at the numerator, my base is the x, my exponent of my radicand is 3, the index is 4, so that would go to x to the power of 3/4. The denominator now, I have x squared and the 8th root of that. So that would go to x to the power of 2 over 8. So now let's look at this. I know I can reduce 2 over 8 to 1/4. So I have x to the power of 3/4 over x to the power of 1/4. And what do I do with the exponents? Well, again, I have the same base. And now I'm going to subtract the exponents. So I have 3/4 minus the denominator 1/4. And 3/4 minus 1/4 will give me 2/4, which reduces to 1/2. Now remember, anything to the power of 1/2 is the square root of, so square root of x. So we could have shown our answer like that, or we could also convert it back into radical form as a square root of x. Let's do another example. So we have the square root of 3 times the 4th root of 3. Now previously I've said that we can't really multiply radicals together that have different indexes. But now that we can convert this into exponential form, we can. So let's convert these. We have the square root of 3, which can convert into this 3 to the power of 1/2, times the 4th root of 3, which can convert into 3 to the power of 1/4. Now, we have the same base, which is 3 and 3, and we can use our properties of exponents. We're going to have 3 to the power of, and now we can add our exponents. So we have 1/2 plus 1/4. But here, let's look at this. We have to add our fractions. We need a common denominator. So what I'm going to do is I need to multiply that 1/2 by something to get the denominator to be 4. And remember, I need that to be a special form of 1. So I'm going to multiply that 1/2 by 2/2. And what that is going to do, it's going to give me 3 to the power of 2/4 plus a 1/4, which I know 2/4 plus 1/4 is 3/4. Not 3/3, 3/4. So there's my answer. You could also write it as a radical. So the 4th root of 3 to the power of 3 would also be an acceptable answer. Alright, so here is another example, and we're going to get a little trickier here. Now, notice I have negative 8x times the square root of xy. Now, all of this is being raised to the power of 2/3. And remember, I have multiple elements. I have a negative 8, an x, and the square root of xy. So I need to distribute this exponent to all 3 of these elements. So if I rewrite that, I will have a negative 8 to the power of 2/3 times x to the power of 2/3 times the square root of x times y to the power of 2/3. Now I need to rewrite this in certain ways. Now if I have negative 8 to the power of 2/3, I can rewrite that as a radical. Sometimes this is an art form. You're going to have to see which way it'll be easier to do it. So the cube root of negative 8, you should know that that is a whole number, which is 2. So I want to do it like this. So I have the cube root of negative 8 squared times, and then I'm going to keep this as x to the power of 2/3. So not really a whole lot I can do with that yet. And now I don't like to have a radical and a rational exponent. So I'm going to switch that radical to a rational exponent itself. So that's x times y in parentheses to the power of 1/2. So that's the square root of xy. And then I'm going to raise that to the power of 2/3. And now I can go ahead and I can simplify it a little bit further. Well, the cube root of negative 8 is negative 2, so I have a negative 2 squared times x to the power of 2/3 times, and now remember when I have a term with an exponent raised to another power, I need to multiply the exponents together. So I'm going to have 1/2 times 2/3, which is going to give me xy to the power of 1/2 times 2/3 is 2/6. And now I'm going to go ahead and simplify it again further. So I would come back to the negative 2 squared. Well, negative 2 squared is 4 and times x to the power of 2/3. And now let's look at this. 2/6 can reduce to 1/3, right? So I'm going to reduce that 2/6 to 1/3. And remember now, again, I have x times y to the power of 1/3. So I'm going to distribute that exponent to the 2 elements, the x and the y. So I have times x to the power of 1/3 times y to the power of 1/3. And again, let's see, I can simplify these because they have the same base again. So I have 4. And what do I do with the exponents? Well, remember when I have the same base, I add the exponents. So 2/3 plus 1/3. I'm going to go ahead and do that right now. 2/3 plus 1/3 is just 3/3, or just 1. And then I have y to the power of 1/3. So there's my answer. I could also write it as 4x times the cube root of y as well.